This lesson focuses on applying exponent rules. There's a few basic rules that we're going to be using. The first one I would say is x to the power of m times x to the power of n equals x to the m plus n. What that means is when I multiply two things with the same base, I add their powers. You're going to see that in problem 1. This says 10 to the third power times 10 to the 8th power. Since they have the same base 10, when I multiply, I take that same base 10 and I combine the powers by adding them, 3 plus 8. That's why I get an answer of 10 to the 11th. I could write this out as a 1 with 11 zeros after it, but I think the answer choices are just stated as 10 to the 11th or whatever the base is being taken to a power. Whenever it is a whole number, you could actually take it to a power and find the numerical answer. For the second problem, we're using a different rule. That rule is the power to a power rule. So it says if we have x to the nth power being taken to the nth power, that gives us x to the mn as an answer. In other words, when you have a single base being taken to a power, all within parentheses being taken to another power, you multiply the two powers. So this becomes b to the 2 times 8, which equals b to the 16th. Problem 3 gives us something to the 0th power. Anything to the 0th power equals 1. So really the reason this is true is because if I have something like the variable x to the first power, it's understood to be multiplied by y to the 0th power, z to the 0th power, or any other variable that you want to say that's not actually really there. The reason it can't equal 0 when you go to the 0th power is because that would make this whole term disappear, and that x actually is there. As opposed to when something to the 0th power just equals 1, multiplying this x by 1 hasn't changed it at all. So whenever you see something to the 0th power, just set it equal to 1. That said, when you have something outside being multiplied by something else to the 0th power, that 0th power thing becomes 1, but the other thing remains. So really, this 0th power applies to anything within parentheses. It doesn't matter if there's multiple letters, multiple numbers within the parentheses. The whole thing being taken to the 0th power still equals 1. But if it has a coefficient out front, that coefficient gets multiplied by the 1. In this case, since it was just 3 to the 0th power, that equals exactly 1. There's no real exponent rule for problem 4. This is more of a combined like terms situation. If I have something to the same exponent plus something else to the same exponent, I can add them. I just have to know how many total I have. Here I have 1x to the 4th. Here I have another 1x to the 4th. That gives me a total of 2x to the 4ths. When I say here I have 1, there's an understood 1 in front of any variable where it doesn't have a number in front of it. Problem 5 asks me to divide two exponents. That gets me to a new rule, which is if I have x to the m over x to the n, it becomes x to the m minus n. Or in other words, you take the power on top, which in this case we have as 12. You subtract the power on bottom, which in this case we have as 2. That's why my final answer here would be c to the 10th. Notice we kept that same base c that was being taken to the exponent. The only thing we manipulated was the power on it. It used to be 12 on top and 2 on bottom. We made it into 12 minus 2, which gave me 10. Problem 6 looks a lot like problem 1, just with x's. So we're using the rule that we used for problem 1, which is when I multiply two of the same base, I multiply them and add their exponents by keeping their base and doing exponent plus exponent. X to the power of 2 plus 3 becomes x to the 5th power. Problem 7 uses my rule power to a power. X to the 9th, all being taken to the 6th power, becomes x to the 9 times 6, or x to the 54th power. Problem 8 requires me to use a new rule. So that rule is that if I have anything to the negative first power, it just becomes 1 over whatever that thing in parentheses was. So in this case, we have x squared being taken to the negative first power. That means it just becomes 1 over x squared. Or I could just really write it as 1 divided by x squared. Problem 9 is like problem 4, where since everything's just being added, I have to see what are like terms and combine the like terms. Everything is an x squared, same variable, being taken to the same power, so I can just say how many total do I have. I have 2 here, plus 3 here gives me 5 total, plus 4 more gives me 9 total x squared terms. Problem 10 is like problem 5. Here I'm doing y to the 11th power divided by y to the 10th power. That means I just have to do power on top, 11, minus power on bottom, 10. That's how I get y to the first. But when you have something to the first power, you don't need to display the power. That's always understood. So you'd see it as an answer choice as just y.